Sedimentary rocks. Sedimentary rocks are divided into groups, whether the first group is called clastic or fragmental. Second group is called crystalline or chemical, and the final group is called bioclastic or organic. So there are three different types of sedimentary rocks: clastic or fragmental, crystalline or chemical, bioclastic or organic. Let's take a look at clastic from fragmental rocks. What are they? Well, clastic rocks form from the fragments or pieces of other rocks and are made up of those sediments glued together. So these rocks are actually made up of pieces of other rocks, and somehow these pieces, by process called lithification, get glued together to form new solid rock. All right, so clastic fragmental rocks are the most common rock at the Earth's surface, and most of New York State is covered in clastic fragmental rock. It's made up of rock that has been made up of pieces of other rock that was worn down. In fact, around the whole planet, it creates a thin shell around the planet that is part of what we call the lithosphere. So, all right, here's another thing about these guys. Let's take a look. Short video.
Rock wall is an example of sedimentary rock. Sedimentary rocks
All right. So what was mentioned in that video is that clastic fragmental rocks, these sedimentary rocks, are made through a process. First, we have solid rock. It could be igneous rock, it could be other sedimentary rock, it could be a type of rock called metamorphic rock that gets weathered away. And weathering means that that rock is broken down. The next is the pieces are eroded, they're moved. We call them moving pieces now. We have given a name, we call them sediments now. So these sediments are moved and eventually they're deposited. And what moves most of these sediments is water. So you see as water runs through the streams, it moves the sediments. Eventually, streams empty into lakes or oceans. It's deposited. Now, what's going to happen is as that river comes into an ocean, it's going to drop off the particles that it had in the river. It's carrying rocks on its riverbed. And if we take a look where it does drop off in, let's say, the ocean, we actually see that it will actually separate into different zones. So we'll have the larger particles near the shoreline, and as we move out, we'll have sand deposit and then silt and clay. And so what happens over time is that this stuff builds up on itself. So more gets deposited, and that weight begins to increase. We call this the process burial. Eventually, that weight begins to compress the rocks buried below more and more. This results in something called compaction, where they get squeezed together. The pore spaces, the empty air spaces between the particles become pretty much null and void, and natural cements start to form. This process is now called lithification, because those weathered particles, which were just little fragments, are now a solid rock. So to create a clastic sedimentary rock, the following steps occur. You have weathering, the large rock is broken down into smaller pieces. We have erosion, the pieces are transported usually by water. We now call those pieces sediments. The pieces are now called sediments. Deposition, the sediments are deposited usually in the ocean. Burial, the deposits bury other deposits, forming layers. Compression, the layers pile up and compress the sediments below them. Compaction, the sediments get squeezed together, and cementation, lithification, natural cements bond the sediments together into a solid rock. So now what we find over time is that the clay area, for instance, will turn into shale, and the silt will turn into a rock called siltstone, and the sand area will turn into an area of sandstone. And then we have the large sand and pebbles that will give us the type of rock called conglomerate or breccia. Okay, so clastic rock. When we look at these rocks, all of the clastic sedimentary rocks may be made of the same mix of minerals. So the minerals that get deposited here could be the same mix all over here. Okay. But what are those minerals? Mostly quartz, feldspars, and clay minerals may contain fragments from other rocks and minerals. But the mineral composition is not a key to identifying these rocks, since they all have the same mineral composition. So how do you identify them? Well, the way you identify them is by what we call their texture. So texture is the particle size or the grain size, the size of the little pieces. And we're going to be looking at many different minerals embedded in those pieces. So we call this a polymineralic rock. Okay. So the 5 common classic sedimentary rocks are distinguished by their texture, which refers to the size of the sediments. And if you look at the chart here, sediment size, the name of the sediment, and the rock, if the sediments in the rock are larger than 0.2 centimeters, so that's 2 millimeters. 2 millimeters might be equivalent to the width of, let's see, well, it's 2 millimeters. We'll get back to that. So if it's larger than 0.2 centimeters, it's going to be made of sediments that are known as pebbles, cobbles, or boulders. Those sediments can either form what's called a conglomerate or a breccia. Now, if the size of the particles is between 0.006 to 0.2, we call those particles sand particles, and that's going to be a sandstone. If the particles are between 0.0004 to 0.006, it should say there, right? That's going to be the particle silt, and that's going to create siltstone over time. And if the particles are less than 0.00004 centimeters, we have clay. And clay forms shale. So conglomerate and breccia both have the same particles to them. They're both made of particles larger than 0.2 centimeters, same types of sediments, pebbles, cobbles, or boulders. But here's the thing about them. They are different. If you look at the way the particles are, in a conglomerate, the particles are rounded. And in a breccia, the particles are angular. So we can tell the difference between a conglomerate and breccia have the same fragments, but are distinguished by whether or not the fragments are rounded. And if they're rounded, they're conglomerate. If they're angular, they're breccia. All right, so what about sandstone? Sandstone's made of sand-sized particles. The sediment size is 0.006 to 0.2 centimeters, and we're going to get a sandstone. A sandstone might look something like this. Sand-sized particles. Sandstone is said to have a fine to coarse texture. And then we have shale and siltstone. Now, particles that make up silts siltstone. It's between 0.0004 to 0.006 centimeters, and less than that is clay. And so here are our 5 clastic rocks. Now, shale is compact and may splitting easy. That's a real clue in identifying shale. Siltstone is very fine grained. So what are some features we find in these clastic rocks? Well, one of them is fossils. Because clastic rocks form in the ocean, many times organisms, whether they're dead or decaying or alive, might be buried in the sand. And if they are killed there and their remains can be preserved in a way or replaced by other minerals, we can get a whole slew of fossils. So you can see a couple different fossils that are common in New York State. One of them is called a trilobite. The one in the middle, up the middle, is called a Eurypterids. It's the New York State fossil, official fossil. We also have horned corals from the Devonian period. Looks like some starfish implants, and those little things that look like coins, those are called crinoid stems. Those are all fossils found in New York State. Here's another thing you'll find in these clastic rocks, mud cracks. So sometimes the sand near the beach dries out and forms these cracks in the sediment. We can also find ripple marks because these are ocean marine features. And we'll notice layers of sediments because, like I said, you start having deposits of layers on top of each other, burying the sand layers below. So when you look around for clastic rocks now, and you open your eyes, you can see some, classic pictures of Grand Canyon, and underneath there's Antelope Canyon. But the other ones are from around New York State, and we have a lot of these layers. Just look as you drive down the road. Now, the importance of the features that we have here is they really tell us about the environment a long time ago. So most of the sedimentary rock in New York State we find is Devonian, and it was deposited between 359 and 460 million years ago. And here's an artist's interpretation of how the shallow seafloor would have appeared. So based upon the rocks that we find now, and we look at the fossils in those rocks, we get a good idea of what it was like here about 359 million years or so ago. Okay, so they definitely tell us about the environment. Now, the importance of the sedimentary rocks is that if we had igneous rocks around here, igneous rocks would melt the features, so we'd have no clues. There'd be no fossils, and metamorphic rocks with the heat pressure crush the features. So having sedimentary rocks is really great. Now, we can get a lot of information on sedimentary rocks on page 7 in the Earth Science reference table.